So good afternoon, everyone. We are Group 7 and we are here to discuss the chemistry of water. So I am Justin Maybacos, the first reporter.
And hello. And I am Ron Barnedo.
And I'm Elias Don Reynaldo.
So, Ron, paano ako ng overview? So before we tackle the chemistry of water, I will read the overview of our reports. So, where does the water come from? What is the chemistry of water? Then the important water facts, and then the water cycle and the real shape of the raindrop. Also, we will tackle the water molecules and hydrogen bonding, then the unique properties of water, and then the diffusion and osmosis, followed by the pH scale and pH, then acids. What is acids, and then bases, and then the litmus paper. So next slide, Ron. So a lot of us wonder, where does the water come from? Is it on the other planets, solar system, or other theories and myths of the known people? So how did our planet end up with so much of this substance? So the answer is still unknown. But I will share one of the ideas or hypotheses led by one known person who studies the Earth's water. So a team from Arizona State University, led by Peter Busek, a Regents Professor in the School of Earth and Space Exploration and School of Molecular Sciences, gave us the idea that was published on October 9, 2018 in the Journal of Geophysical Research. So they said that Earth's water comes from rocky materials, like a big asteroid or possibly in a cloud of dust and gases that was left when the sun was created, or known as a solar nebula. But they were hesitant at that time if the solar nebula is really the answer why there is water on Earth, because there are lack of DH ratio to supply the Earth with water. That's why they have a huge belief that the water really comes from asteroids. So paano nga ba nila nasabi na yung tubig ay nanggaling sa rocky materials or sa asteroid? They knew that the water what we can see in oceans as the water that they have seen inside the asteroids are the same. Tapos, it's because they have nearly the same chemical deuterium to hydrogen ratio, or known as DH ratio, or a unique chemical ratio according to the identity of our liquid water. So, to give you an idea, yung DH ratio po is, sa madaling salita, ito yung medium o susi para malaman kung saan parte ng solar system nanggaling ang isang uri ng bagay at matukoy ang proportion o ambag ng asteroids o comets sa ating Earth's ocean. At isa pa, ito rin yung way para malaman natin yung interaction ng mga fluids at rocks, tapos malaman din geologic history ng mga fluids. That's why a lot of people agreed with their conclusion that the Earth's water comes from asteroids that have fallen on our planets after the asteroid's cover, or the magma itself, which covered the asteroid, was completely dried, or known as basalt. So yung basalt naman, yung parang cover ng asteroids na natuyo, is pinaka most common composition ng lava rocks na natuyo o sabihin natin lumamig from magma. Ito yung liquid rocks that rises from the deep earth at volcanoes. Tapos ito rin yung bato na either black or grayish black yung kulay na makikita natin all over the earth. Also, ginagamit din ito for constructions like building blocks or sa groundwork. Tapos paggawa ng cobblestone tsaka statues. Tapos to give you an idea din, yung difference between asteroid and meteor. Yung asteroid is a small rocky object that orbits the sun. While yung meteor naman is yung isa siyang small piece ng asteroid or comet na tinatawag na meteoroid. Tapos nagbe-burn siya upon entering the Earth atmosphere. So, however, as I said, all the information I have said earlier is just a hypothesis. Up until now, experts, scientists, astronomers still debate and discover where the Earth's water comes from. So, next slide. So, the chemistry of water, or what is water? So, water is a phenomenal substance. So, aside na rin sa ito ang pinaka-importante at numero unong inumin sa buong mundo, hindi lamang kilala ang tubig sa pangsarili nating gamit, kundi na rin sa mga hayop, halaman o likas na yaman ng ating bansa. Tsaka isa pa ay napaka-importante din ito sa engineering fields, lalo na sa mga engineers na nagde-develop ng water supply, irrigation, navigation at hydroelectric power. Tapos, kung saan naman nag-o-occur yung tatlong states ng tubig o uri ng tubig. Halimbawa na lang sa yaman tubig o specifically sa dagat sa ibang bansa. Madalas nag-o-occur yung solid states, ice, frost, o snow, tuwing November o mid-December. Tapos, meron namang umabot ng 10 months tulad sa Arctic Ocean. Tapos yung pangalawang uri naman ng tubig is yung liquid state. Halimbawa na lang ay ang tubig, gatas o dugo na nakikita natin araw-araw. Tapos yung pangatlong state naman is yung gas state. Halimbawa na lang ay ang water vapor, carbon dioxide at saka oxygen. At alam niyo rin ba ang pinaka-main compound na makikita natin sa living organisms ay ang tubig, na kung saan around 62% sa ating katawan ay consist ng tubig. At isa pa, ito rin yung chemical compound na gawa o consist sa dalawang atoms o sabihin natin tatlong atoms kasi dalawang hydrogen tsaka isang oxygen atom. So, next slide. So, other important water facts. So, ang totoong kulay ng tubig ay transparent o nearly colorless. Hindi blue o green na makikita natin sa dagat, at hindi rin light gray na makikita natin sa ating mga tumbler kasi mostly mga bata. May mga nagtatanong o nagsasabi bakit light gray na yung kulay ng tubig. Tapos, around 71% naman ng Earth's surface ay sakop ng tubig. At ang natitirang porsyento nito ay occupied naman ng 7 continental landmasses, which are Asia, Africa, North America, South America, Antarctica, Europe, at saka Australia. Tapos, idagdag niyo na rin na 2.5% lamang ng tubig ay fresh o sariwa sa buong mundo. Tapos, isa pa ay ang tubig ay pinakasagana na molecule sa buong daigdig. At alam niyo ba na ang molar mass ng tubig ay 18.01528 grams per mole. Tsaka yung melting point naman nito is 0 degrees Celsius o katumbas ng 32 degrees Fahrenheit at 273.15 in Kelvin. So, pag kumukuha kayo ng yelo galing sa freezer, pag once na kinuha niyo, nag-start na magme-melt yun palabas. Tapos, yung boiling point naman nito is 99.98 degrees Celsius, rounding off to 100 degrees Celsius o katumbas ng 211.96 in Fahrenheit at 373.30 naman in Kelvin. Tapos may bigat o density rin itong 997 kg per cubic meters. At ang huling water facts naman ay ang tubig ay isang amphoteric. It means it is capable of reacting chemically either as an acid or as a base, na itatakal naman ni Mr. Ron Pellias ang tungkol dyan mamaya. So, after the important water facts, ngayon naman itatakal ko yung water cycle. So, next slide, please. So, the water cycle or hydrologic cycle is a biogeochemical cycle that describes the continuous movement of water on, above, and below the surface of the earth. So, yung first step ng water cycle is evaporation. So, wherein the water at the surface turns into water vapors, and the water absorbs heat energy from the sun and turns into vapors. So, yung pinaka-main sources ng evaporation is yung oceans, lakes, tsaka rivers. So, yung pangalawang step naman sa water cycle is condensation. As water evaporates into water vapor, it rises up in the atmosphere. At high altitudes, the water vapor changes into very tiny particles of ice or water droplets because of low temperature. So ito yung process na condensation. Yung particles niya is nagko-close or nagka-come close together para makabuo ng clouds tsaka fog sa sky. So, aside sa evaporation, meron din tayong sublimation, which is yung pangatlong step ng water cycle. It also contributes water vapors in the air. It is the process where ice directly converts into water vapors without converting into liquid water. So this phenomenon accelerates when the temperature is low or pressure is high. So yung pinaka-main sources naman ng sublimation is yung ice sheets sa North Pole tsaka South Pole tsaka yung ice caps naman sa mountains sa ibang bansa. Tapos, in addition din, yung sublimation, ito yung pinaka-slower process besides sa evaporation. So yung step 4 is precipitation. The clouds condense water vapors, then pour down as precipitation due to the wind or temperature change. This occurs because the water droplets combine to make bigger droplets. Also, when the air cannot hold any more water, it precipitates. So yung precipitation, ito yung action or process of precipitating or changing a substance from a solution. Example na lang pag high altitudes. So yung temperature talaga is low, then yung droplets din ay nag-lose ng heat energy. Kaya pag bumabagsak yan dito sa lupa, ang resulta is yung pag-ulan o umuulan. Pero pag yung temperature naman niya is very, very low, sabihin natin mga below 0 degrees, magre-result naman yun ng pag-snow, which it occurs in the other countries such as in America, Korea, and many more. At ito pa, yung water din, nagpe-precipitate din siya or nag-change into the form of drizzle. Or sabihin natin ambon, alam natin is ambon dito sa Yung sleet din. Yung sleet naman is nagmimix yung rain tsaka snow. Tapos yung pangatlo is hail. Yun yung solid na big ice. Para siyang kamaon ng bata. Yung pagka-yellow niya, para siyang kalaki siya nung kamaon ng bata tapos bilog na bilog. Tapos dito naman yung water, naka-enter na siya sa lithosphere, isa sa mga earth system natin. So yung step 5 naman is transpiration. As water precipitates, some of it absorbed by the soil. This water enters into the process of transpiration. So transpiration is a process similar to evaporation, where liquid water is turned into water vapor by the plants. The roots of the plants absorb the water and push it toward leaves, where it is used for photosynthesis. The extra water is moved out of leaves through stomata. So yung stomata is a very tiny opening on leaves as water vapor. Tapos yung water naman dito is naka-enter na siya sa biosphere, tapos nag-exit into a gaseous phase. Yung step 6 naman is runoff. So as the water pours down or in whatever form, it leads to runoff. Runoff is the process where the water runs over the surface of Earth. When the snow melts into water, it also leads to runoff. Then as water runs over the ground, it displaces the topsoil with it and moves the minerals along with the stream. This runoff combines to form channels, rivers, and ends up into the lakes, seas, and oceans. So yung water dito is naka-enter na siya sa hydrosphere. So yung last step ng water cycle natin, yung pinakababa, makikita niyo dyan sa picture, is yung infiltration. So some of the water that precipitate does not run into the rivers and is absorbed by the plants or gets evaporated. It moves deep into the soil. Tapos ito yung tinatawag na infiltration. So the water seeps down and increases the level of the groundwater table. Tapos ito yung tinatawag na pure water tapos or drinkable. The infiltration is measured as inches of water soaked by the soil per hour. So after I've discussed the water cycle, let's tackle the real shape of the raindrop. So next slide, please. So the real shape of raindrop. So ano nga ba talaga yung totoong shape ng raindrop? Is it ito ba yung nasa kaliwa o nasa kanan? So discuss ko yan. Well, some cartoons and some science diagrams draw raindrops in that shape. Itong shape na nasa left. Raindrops are neither tear-shaped nor spherical. Due to the interaction of cohesion, surface tension, air resistance, and gravity, large raindrops are shaped more like the top half of a hamburger bun. So yung totoong shape talaga ng raindrop is itong nasa kanan. Ayan, yung nasa mouse. Ay, yung pinopoint ng mouse, yung cursor. Ayan, yung parang ng mga aliens kaya. Charot. Tapos, ibig sabihin, yung nasa peak na ito, yung nasa left, yun yung pinaka-common misconception nating mga tao tungkol sa real shape ng ulan. Tapos, itong picture naman na nasa kanan, itong nasa left, di ba, yan yung pinaka-common misconception. Tapos, yan yung tinatawag na teardrop o yung tubig na mula sa ating mga mata. So, after I have discussed my part, Mr. Barnado will start his part 2. So he will tackle the water molecules and its unique properties. So Ron, it's your turn. Tapos na ako.
Hello everyone. Today I'm going to report to you about the water molecule and the unique property of water. First is what is water molecule? Water molecule is a molecule because it contains molecular bonds. Water is also a compound because it is made of from than one kind of element, oxygen and hydrogen. These types of molecule is called a diatomic molecule, a molecule made from two atoms of the same type. So what is a molecule made of? Water molecule is made of atoms that join together to form a molecule. A molecule has three atoms, two hydrogen atoms and one oxygen. Water makes up approximately 60% of the adult human being's body weight. Now, an attractive force called a hydrogen bond can exist between certain molecules. These bonds are weaker than ionic or covalent bonds because it takes less energy to break types of bonds. However, a large number of these bonds going on can exert a strong force. If we look at a water molecule, we can see the oxygen atom shares electrons with two different hydrogen atoms. So in total, this molecule has 10 protons, 8 from oxygen, and 1 each from hydrogen. Another total of 10 electrons, 2 shared between the 1 each from hydrogen, and another total of electrons between the oxygen atom and hydrogen atom number 1, and 2 shared between the oxygen atom and hydrogen atom number 2, and the other 6 non-shared electrons from the oxygen atom. So what is polar? Polar is a unequal sharing of electrons between the atoms and the unsymmetrical shape of the molecule means that a water molecule has two poles, a positive charge on the hydrogen pole and a negative charge on the oxygen pole. What happens when water is polar? While there is not a net charge to a water molecule, the polarity of water creates a slightly positive charge on hydrogen and slightly negative charge on oxygen, contributing to water's properties of attraction. Water's charges are generated because oxygen is more negative or electron loving than hydrogen. To determine whether which atom has a stronger force on attacking the shared electrons, we need to look at the following electronegativity table ito. Electronegativity is a measure of the ability of an atom to pull electrons towards itself. Here we can see that oxygen is higher electronegative value than hydrogen, thus the oxygen atom would have a stronger force on attracting the shared electrons when it bonds with hydrogen because the shared electrons are pulled closer the oxygen atom, it gets a slightly negative charge while the hydrogen atom gets a slightly positive charge. Para malaman mo naman kung alin dyan yung pinakamataas at pinakamababa at pinakamataas, magsisimula ka muna sa kaliwa pupuntang kanan. Yung kaliwa, yun yung pinakamababang electronegativity. Sa kanan naman, papunta naman sa kanan, yun yung pinakamataas na electronegativity. In short nun, in EN, capital EN. So we know that a water molecule are polar or have a slightly negative end. Many lipids or fats and oils are not polar. Oil never mixes with liquid water because it is a non-polar molecule. Its electrons are shared equally, so it has no positive nor negative region, and this lack of charge would mean that a molecule is non-polar. Instead, it creates a soft surface layer of soil on top because water is denser than oil. In chemistry, only like dissolves like as this applied on the solubility and miscibility because oil has no charge or any polar part. It is not capable of breaking through the hydrogen bonds between the water molecules, so it never mixes. Like hindi sila ugnay sa isa't isa. Nagkakaiba sila. Example nito ay ang oil at water, methane and water. At isa pa nito ay ang soap because soap is oil and grease because soap is amphiphilic or a surfactant. One end of the soap molecule is polar and is soluble in water, while the other end is non-polar and is soluble with oil and grease. Therefore, the soap molecules work as a bridge for oil and water to mix. In the same way, why soap is very effective in fighting COVID-19 for the virus is mainly made up of its spike protein, a bilayer of lipid or fat that protects the genetic materials inside it. Washing our hands every day is keep us from infection. For the water has a corrosive and adhesive. The ability of water to stick to itself is cohesion. Ito yung cohesion naman, ito yung tuwing yung basa, yung tubig tumitikit sa isang bagay, nakikita mo pa rin yung form ng shape ng water. While its ability to stick to another surface is called adhesion. Sa adhesion naman, ito naman, malalaman mo kapag adhesion ito, kapag ito ay nagiging basa sa isang bagay or sa isang surface. Kunwari itong pawis, dire-diretso lang siya or nagmumukha siyang basa at yung tubig, pag tubig tumikit siya sa panyo, nagiging basa na siya. Hydrogen bonds, water is less dense because hydrogen bonds keep water molecules farther apart in frozen water than in liquid water. The further apart the molecules are, the less dense than solid is. So ice is about 90% dense than water, which means it floats on the top. That's why lakes freeze from the top, top down, and aquatic life can survive through cold winter every year. An example naman nito yung ships, submarines, and floating in swim. Yung pag nag-float ka swimming, nalulutang ka. Dahil yung tubig ay less dense talaga. So water has heat capacity. There are two reasons. One of them is that water molecule is bent. It is rational asymmetric, meaning that it can be store more energy in the rational degrees of freedom than other symmetric molecules, like a diatomic molecule of CO2. The other and more important reason are the hydrogen bonds. When a hydrogen bond atoms binds with a more electronegative atom. Now we go back to the simulation. Where? Ito naman, tuwing lumalamig, yung mga molecule, nagdidikit-dikit tuwing sobrang lamig. Yan, makita, kaya nagpo-form din ng crystallization structure tuwing naging malamig yung water. Tapos habang pag binagyan naman to ng init, yung mga molecule naman nagwawala. Naggugulo kung saan na pumupunta dahil sa heat pressure or dahil sa init silang dahil sa init nagbibigay ng kasi tas hanggang sa lumala yan kung saan na talaga na pumupunta ang mga water molecule. Now, this can be also explained by crystallization structure of ice when water molecule cool down, they vibrate less as the temperature is freezing. These slow-moving molecules large onto each other at the specific points, creating um, creating temperature, freezing rigid iced crystals with a distinctive lattice shape, the relatively large space between frozen water molecules. It's the reason the ice is more voluminous than water and likewise less dense. Kapag mainit naman, when heat is added on water, the vibration of its molecules increases, causing the water to expand. Yeah, yan. Nag-expand, lumalayo. So isa't isa, causing the water to expand. Molecules vibrate faster. They bounce around, pushing others away, causing the space between them to increase. Balik tayo sa PPT. Now, water has a high heat of evaporation. What hydrogen forms readily between the oxygen and one molecule and has a bizarrely high specific heat. In general, it's the highest of liquids due to hydrogen bonding between molecules. This means the water can absorb heat energy before changing temperature. The energy goes into breaking hydrogen bonds. It takes a lot of energy to make water increase in temperature. Water is solvent. Water is an excellent um, solvent because of its polarity and high dielectric constant. At saka ito ay isang universal solvent dahil yung water mas madali siyang paghaluin kung ano-anong like yung salt, sugar, like isa rin yung example yung juice, coffee, ganyan. Yung nakikita niyo na nagkahalo na tas nag-iiba yung kulay. Kaya sobrang solvent ng water. At pwede mo rin siyang pag-experiment yung water. Ngayon may present akong video about sa water molecule kung ano yung tsura nila. Share somebody.
This short video is going to show you a little bit about those intermolecular bonds that you see between water. So it's a silent film and I'll just narrate through this. And you notice that here you have two hydrogen gas molecules. Remember, hydrogen comes in pairs. Those are in green. And then the blue ones are the oxygen gas molecules. Those are diatomic. And when they come together, a chemical reaction happens where you have water H2O. You see on the top, those red areas are your hydrogens, where you have more the protons with the negative charge being more towards the bottom. And you notice that that positive charged hydrogen is going to have a hydrogen bond connected to the negative charge of the water molecule, keeping in mind that negatives and positives attract. And so these are called hydrogen bonds, and they're incredibly important bonds for all of life. And here you notice that we're having water form in liquid form because those hydrogen bonds are bonding, the positive always connecting to the negative. In this next video, what you're going to be looking at is how water molecules look differently in liquids, solids, and gases. So here you see actual motion ever so slightly. These here are, however, not moving around each other, but seem to be fixed in one location, and this would be considered a solid, such as ice. And in the next part, you'll notice that it has a real rigid structure, a crystalline structure, with lots of air in between. And this is why ice is actually less dense than the liquid form of water, because you have those air molecules in between. Again, taking a look that those positively charged hydrogens are going to be connecting to the negative region of the water, being the oxygen. In the gas state, on the other hand, you still have these water molecules, but as a gas, they have no hydrogen bonds connecting them, but are purely flying randomly throughout and knocking into each other. They just are moving too quickly to bond.
For the next reporter, tinatawag ko na po si Ron Perias.
Next slide. Next slide, please. Mixing due to molecular movement is called diffusion. All particles of matter are constantly moving. Gas molecules move in straight line until colliding with other molecules, while liquid molecules slides in one direction but are pulled by the bonds they have with the molecules around them. Even in solids, atoms move by vibrating in place. Equilibrium to reach when the two substances are evenly mixed. Next slide. Diffusion. Diffusion is when the net movement of a substance traveling down its concentration gradient. That means it moves from a high concentration to a low concentration. What is a high concentration of water and low concentration of water? It simply means that in a low level of water, there is a higher level of solutes like salt and sugar, while the higher concentration area has no or fewer solutes in it. Example, when we put a medicine to a water, the medicine will travel in the water through diffusion. The high concentration of molecule, which is where the medicine is dropped, and it will spread to areas of low concentration of water. Next slide, please. Osmosis. What is osmosis? Osmosis is a movement of water. Osmosis is the diffusion of water across a semi-permeable membrane. A membrane is like a net, will not let bigger molecules through, and some small molecules will collide and bounce back. Next slide, please. pH scale. First of all, what is pH? pH stands for potential of hydrogen. Potential of hydrogen is a measure of the concentration of hydrogen ions in a water-based substance. The pH scale describes how acidic or basic a solution is. A solution is any mixture with one or more solutes distributed evenly in solvent substances. With pH less than 7 is acid, a pH of 7 is neutral, and substances with pH higher than 7 is bases. We can tell if something is acidic, alkali, or neutral by using an indicator. Indicator are substances that shows different colors when they are in acidic or alkali. Litmus paper is a simple indicator that tells us whether something is acid or alkali. Litmus paper is red in acid and blue in alkali. Litmus paper is made of lichens which been used to dye clothes for hundreds of years. However, litmus paper only tells us whether something is acidic or alkali, but it does not tell us how acidic or alkali a substance is. This pH scale from the picture runs from 0 to 14, with 0 being extremely acid, 7 being neutral, and 14 being extremely alkali. The pH scale describes how acidic or basic a solution is. Example, battery acid, substances with pH less than 7 are acids, and the examples are battery acid, hydrochloric acid. A pH of 7 is neutral, and the example of it is water and blood. While pH higher than 7 are bases. Example of it is bleach and drain cleaner. Next slide, please. pH. pH stands for potential of hydrogen ion. When a substance dissolves in a solution, the molecules will break apart. In acids and bases, the broken apart molecules form either OH negative or H plus. Or what we call the OH negative stands for hydroxide, and the H with a positive sign stands for hydrogen ion. The more hydrogen ion, the lower the number of the pH scale and the more acidic it is. Log scale means 10 times change per unit. Next slide, please. Acid. What is acid? A chemical substance that neutralizes alkalis, dissolves some metals, and turn litmus red. The moment we hear the term acid, something scary or something that would burn the surface is what comes to our mind. Well, that's kind of true. Because acids are known to create a burning effect, whatever comes in contact with them. They can erode the surfaces or erode the skin. The word acid comes from the Latin word acidus, which means sour. The taste of acid is always sour. The best example of that contains acid is fruits like orange, lemon, lime, and grapes. This is some example of strong acid. Hydrochloric acid, also known as muriatic acid. This is corrosive to the eyes, skin, and mucous membranes. Hydrochloric acid also appears in the human body as an integral component in the digestive system. Another example of strong acid is nitric acids. It is used in agriculture, dissolving golds, explosive, fertilizer, water treatment. It is also corrosive to the skin, producing burns, ulceration, scarring, dermatitis, and yellow staining of the skin. And now, some example of weak acids. Sulfurous acid is an example of weak acid. It is used in the manufacture of fertilizers, pigments, dyes, drugs, explosive, and detergent. Aqua regia is a mixture of nitric and hydrochloric acid. It has the ability to dissolve gold for 4 hours. Next slide, please. Bases. A pH above 7 is a base. Bases also described as alkaline. Alkali are more soluble in water or natutunaw siya sa tubig. Example of strong bases are bleach, oven cleaner, and drain opener. Habang ang weak bases naman ay ang baking soda, eggs, ammonia, and dish soap. Alkali materials are usually used to make cleaning materials, cleaning products like soap and ceramic such as tiles. If you expose it to red litmus paper, it should turn blue. Strong bases or alkali are dangerous. It is corrosive. The example of bases is baking soda, washing soda, quicklime, and many more. Next slide, please. Oh, in this picture, you can see a litmus paper. This is the indicator that I told you a while ago. I'm gonna explain it again. Litmus paper is a simple indicator that tells us whether something is acid or alkali. Litmus paper is a red in acid and blue in alkali. Litmus paper is made of lichens which been used to dye clothes for hundreds of years. However, litmus paper only tells us whether something is acidic or alkali, but it does not tell us how acidic or alkali a substance is. Next slide, please. Oh, we're done. I think that's all. I hope you learned something. Thank you.